Hello everyone, welcome to another video. Today we're going to look at the graph of the truncus. What the truncus is I don't know, there's an easy way to, when you see the shape of it, looks like a trunk of a tree. But the equation, the basic equation is y equals 1 over x squared. So let's just have a look at what it looks like. Just like y equals 1 over x, as it gets bigger and as x gets bigger and bigger and bigger, y gets smaller and smaller and smaller. It never quite gets to zero, but it gets smaller and smaller and smaller. As x gets smaller and smaller and smaller, in other words, as it goes that way, y gets bigger and bigger and bigger. Okay, so it comes up, and again, just like y equals 1 over x, it gets closer and closer, but never ever quite gets to x equals 0. It can't equal 0. So it looks like that. But how it's different to y equals 1 over x is if you think about negative values of x, when you square a negative value, it's going to get positive. And so what happens is that actually this side is actually a mirror image, and it actually looks like this. So it comes up like a trunk, looks like a trunk of a tree. You know, look like a trunk. Look like a tree? Kind of. Okay, so truncus. And so it looks like that. What do we have? We have an asymptote on the y-axis. We have an asymptote on the x-axis, and so it looks like that. So we have an asymptote at, oh, okay, I did that last video too. Asymptote at x equals 0, and asymptote at y equals 0. Okay, so the domain for this function is all real values except for 0, and the range is, once again, all real values except for 0. So there's our basic function of our truncus. So in general, what does it look like? I'm just going to delete the bottom of this because it's just annoying me a little bit. Oops. Anyway, I'm just going to keep on leaving myself not enough space. Just put that axis back in. All good. And so let's have a look at what happens. I'm going to draw two. So what happens if we have some transformations of A, H, and K? So once again, if you have an asymptote at x equals A, H, I don't know why I said A, brain has gone to mush, and you're going to have an asymptote at y equals k, just like for our hyperbola, and you're going to have, oh man, curve there, and your curve going up like that for those two asymptotes, okay? And so that's what it would look like if A is greater than 0. So if A is positive, you're going to get look like that. If A is negative, then you get a flip, just like with our good friend the hyperbola. So again, x equals h, y equals k. But if A is less than that, then we actually get a flip. It goes upside down, gets reflected in an asymptote. That's if A is negative, so A is less than 0. So hope that sort of makes sense about sort of how that shape works. And that allows us to sort of sketch any of these hyperbola. So let's go. Oh, I didn't say the domain and the range. The domain is all real values except for h, and the range is all real values except for k. Gee, I'm getting lazy with those curly brackets, but there you go. All good. Let's have a look at this sketch. So we're going to get asymptotes when x equals 3. We're going to get another asymptote when y is equal to negative 1. So let's put that onto our graph. So we're going to have x equals 3. That's my value. So x equals 3 is there. And we're going to have negative 1 as that. Because our value of A here is positive, that means it's going to be like facing upwards, sort of normal sort of direction. And so it's going to come through. Again, it might be helpful to find an x-intercept and y-intercept. For this video, it's very similar to hyperbola. I'm not going to bother. I'm just going to sort of show you the shape of these things. So it comes up. But if you want a more accurate graph, then that's virtually what it is. So that's my graph, y equals 2 over x minus 3 squared minus 1. Again, if you want the x-intercept and y-intercept, just sub in x equals 0, y equals 0, etc. To find those. I'm not going to bother in this case because it's very similar to hyperbola. You will notice that when you're finding the x-intercepts, you'll get two values. Okay, you get for this one, you get a value there and a value there, and that's because of the squared. You get plus and minus. Hope that makes sense. That's just my phone. I'll get back to that in a second. So hope that makes sense. Last one. So let's determine the equation of this. So what have we got here? We have a function, and we've got an we got f of x. So f of x, we're going to have an a on the top. On the bottom line, what is my vertical asymptote? It's x minus 1. So here it's going to be x plus 1 squared because it's a truncus. And then my horizontal asymptote is 2, so it's going to be plus 2. And so can we find that value of A? We've also got the fact that it goes through the origin here. So we can put that in, so that'll be nice. So we're going to sub in 0, 0. And we'll get 0 equals A over 0 plus 1 squared plus 2. Sort it out. 0 equals A over 1 squared, so it's just A plus 2. Therefore, A is equal to negative 2. Therefore, my equation is negative 2 over x plus 1 squared plus 2. Now, does that make sense? We've got a negative value for A here. A negative value for A, and yes, it's upside down curve, and so that makes sense. That would seem correct. Hope that makes sense. I'll see you in the next video.